Okay, let's look at the kidney for Bio 26. This structure right here on the outside of the kidney would be the capsule. That's the connective tissue layer. The first layer on the outermost portion of the kidney, this is the cortex. Then inside there's these triangular shapes within the medulla. The medulla is this whole section. These triangles within the medulla are the renal pyramids. Then there are these renal columns. These are connective tissue structures separating the renal medulla. And at the very end of these renal pyramids, you have papillary ducts or papilla that enter into this minor calyx. Minor calyxes feed the major calyx, eventually into the renal pelvis, which then drains into the ureter here, right? You can see the hilum, where the renal pelvis is, has arteries, veins. Speaking of arteries, we have the renal artery, which forms a segmental artery, the interlobar artery to the arcuate artery along the border of the cortex and medulla. And then you have the cortical radiate arteries. And in this part of the kidney, you can see these little balls off of the cortical radiate. So this would be an afferent arteriole with a glomeruli. Okay, so those are a little cartoonish and too big. So let's get a blow up of the cortex. So let's look at this part. We can see here again, this is the capsule. This is the cortex region, and then this would be the medulla, okay? So first of all, let's look at the blood vessels. This would be an arcuate. This would be cortical radiate, and these are afferent arterioles here. These little red balls, those are glomeruli. And actually, if you were to take a glomeruli and cover it with a Bowman's capsule, like here, here, and here, you would have what we call a renal corpuscle. These little balls are renal corpuscles. And in our cartoonish model, we have some that are connected to these loops that go below the medulla, but not that much, and others that go almost the whole way into the medulla. So renal corpuscle plus all these tubules, that's a nephron. The one that goes deep into the medulla is a juxtamedullary nephron. The one that stays mostly in the cortex is the cortical nephron. Most of the nephrons are cortical nephrons. Now, we're going to name the first stretch of these tubules the proximal convoluted tubule, and that's going to start to go down. This is going to form the loop of Henle. It's thick, it's thin, and then it's thick again. And this loop here is the loop of Henle. Then eventually we're going to migrate away from the medulla into the cortex and towards this collecting duct. You notice how this passes close to the renal corpuscle. This is the distal convoluted tubule. That's not a mistake on here. And so the distal convoluted tubule comes and it's going to connect to the collecting duct here, right? And the collecting duct ends with a renal papilla. The nephron is important because we have the renal corpuscle, which is involved in creating the filtrate, right? We have the proximal convoluted tubule, the loop of Henle, and the distal convoluted tubule, along with the collecting duct, which all are involved with reabsorption and secretion. Okay, so some examples of how the blood vessels would look. So these nephrons, the juxtamedullary that go deep into the medulla, would have these arteries associated with it. They start at the efferent arteriole. Those would be the vasa recta. See how they're nice and straight? the cortical nephrons would typically have these vessels called the paratubular capillaries, which just wrap around the cortical portion of the nephron. Okay, let's take our renal corpuscle and blow it up. Here we have a renal corpuscle, and it's sliced in half. And you can see a number of things. First, you can see an input blood vessel and an output blood vessel. Both of these are arterioles. Yes, that is weird. Very unusual in the body. So this incoming arteriole, it's a little bit bigger. It's the afferent arteriole. Okay? These vessels, these are capillaries called the glomerular capillaries. Okay? On top of them, they have this covering called a podocyte that form these filtration slits, as you can see here. This is the visceral epithelium. The parietal epithelium out here, this simple squamous shape, forms the outside of the Bowman's capsule. So the podocytes, the simple squamous epithelium capsule, these both form Bowman's capsule. The capillaries are the glomerulus. Together, that's the renal corpuscle. Okay, so filtrate is going to be made by the high pressure blood coming in the afferent arteriole into the glomerular capillary. It's going to exit through these slits, the filtration membrane, and fluid is going to exit into this proximal convoluted tubule. You can notice that these are cuboidal cells, and they're trying to draw in that it should have microvilli, right? And blood is then going to exit into the efferent arterioles. Okay. Efferent arterioles can become paratubular capillaries or vasa recta. Two more details we should talk about is the juxtaglomerular apparatus. Okay, where is that? So one, the distal convoluted tubule, right? Let's go back here for a second. That was this guy. Always is going to come and form a border region with the afferent arteriole. This portion facing the afferent arteriole is called the macula densa. These smooth muscle cells here from the arteriole are the JG cells. And these are going to be important for detecting both blood pressure, glomerular filtration rate, and also osmolarity of the filtrate and the blood.